Hello and happy Tuesday. Welcome to this latest edition of our Bic Gardner webinar series. My name is John Kowalski. I'm part of the marketing team here at Bic Gardner. I'd like to welcome you. Today's topic, innovations in production dispersing and milling. We have our director of VMA-Getzmann for the US and Canada, Mr. Andreas Stummer. He'll be joining us today and sharing his knowledge. This presentation will last about 45 minutes. Then we'll have a little bit of time for questions and answers. If we do run out, we'll contact you individually to make sure we get all your questions and comments answered. Also, we are recording this, so immediately following the presentation, you'll receive an automated marketing link. Feel free to watch this again, share it with colleagues, whatever you like. Also, in the comments, I did put our Dispersing YouTube channel link there, so you can copy that and paste that in your browser. That has all of our webinar archives are there. We have some tours of our Wallingford, Connecticut lab as well, and some other things. So check that out. So with that, if you do have questions or comments, please log them in the chat box. That should be in the bottom right-hand corner of your screen, and we'll get to them time permitting or after the fact. So with that, Andy, how you doing today, sir? Your microphone might be muted. Maybe. Andy, there you go.
Thank you, John.
Yeah, how you doing, sir?
I'm doing great. Thank you for the nice introduction, and welcome everybody to our talk today. Today we're going to cover some new innovations in production dispersing and milling. And as John said, please, at the end of the presentation, please log your questions and we can cover them to make sure everybody gets their questions answered. So here is just a quick slide showing you the last European coating show where we had a really nice booth at VMA, and we had some production smaller scale dispermats on display on the right-hand side. You can see, but VMA, and we'll cover that, is not only known for production equipment. We do everything, as you can see right here on that slide, from small lab scale all the way up to pilot and then to manufacturing. These are just some examples of the different product lines that we offer. We make even smaller units, so even larger than what you can see right here on the picture. So as we go through the presentation, I'd like to give you guys just a quick introduction of the VMA-Getzmann company and the relationship with Bic Gardner here in the US. And then I like to just go briefly the process, cover the dispersion process. Not in too much detail. This is more equipment related today. And then we're going to go through some of the different types of dissolvers and basket mills and horizontal mills that we have for production. And then we'll talk a little bit about the resources that we have in our Wallingford lab in Connecticut at Bic USA, and also at VMA in Germany, if you like to visit. It's a really nice lab. So the couple up on the picture on the top right is a really nice couple, Herman and Elke Getzmann. Herman is actually the founder of VMA-Getzmann. The company was founded in 1972. It's still in family hands. So the two sons, Christian and Martin, are now managing and running the business. They're about 30 miles east of Cologne, which is kind of in the center of Germany. It's a pretty nice developed facility with a lot of resources to design new types of media mills. So they are known for about 40% of everything that VMA manufactures is custom. So there's a lot of new end-use markets, as you know, battery and fuel cell. They require certain types of equipment with the different types of materials. So they have a lot of different design options, and they have some new engineers that help design these machines for these end-use markets. But again, the company was founded about 50 years ago, 52 years ago. And Big Gardner and Big has had the exclusive distribution rights since 1988. So basically, what happened was the old CEO from Big brought over some disper mats to the US in the early 80s, and I've been Wallingford at their facility, and he had customers come in. And as they toured the facility, they all said, wow, these disper mats look really nice. We would like to also purchase some of them. But VMA didn't have any source or location in North America. So the decision was made that by 1988 we would bring that product line on over here and have it as part of our Big Gardner product line. So that's when we signed all the agreements, and we have become the exclusive distributor for this product line in 1988. So we cover everything in the States and Canada, from lab to pilot, as well as manufacturing. And as I mentioned earlier, it's still a family-owned business. They have over 100 employees and about 10 people now just exclusively in the design department. And VMA, they own the Dispermat trademark. Most of you have heard of the Dispermat, and they are known to make really high quality bead mills, dissolvers, different types of milling attachments, rotor stator attachments, vacuum systems for lab, pilot, as well as production. The picture right there on the bottom is the very first Dispermat that was introduced in 1973. And we actually still have customers today that are still using the original Dispermat with the same motor. These are brushless step motor that are used. And if you ever used the Dispermat, you would know that they are extremely quiet. There is nothing else like that on the market with dissolvers that are that quiet as a Dispermat. So here's just a quick picture of the facility in Germany. So they added on some new floors and more capability to the building in the middle. Again, they have 10 people in the design department, and a lot of products that they make today are custom. So it's really good to have the capability. And they also have a really good technical laboratory at VMA in Germany, where customers can come in and do trials and look at the equipment. So with that, I just want to give you a quick overview of the dispersion process before we dive into the different types of equipment. But it's really important. I always like to cover that and just talk a little bit about the process and what we're actually trying to accomplish. So when we disperse, it's important to understand what we're doing is we're just trying to break up these invisible binding forces. They're called Van der Waals forces, and turn these larger agglomerates. These are these building blocks that you can see there. These are basically particles that are fused together with these invisible, almost electromagnetic Van der Waals forces. And all we really want to do is break up the binding forces. We don't want to really destroy the pigment or the particles. We just really want to just break them up and separate them and turn these larger blocks into aggregates. And then once we're at the aggregate level, then the next step is to get down to the primer particle size. And that's what we do when we disperse. Of course, we use different technologies. So when we go in from the agglomerate down to the aggregate, we use a standard dissolver with a cowl's blade or these impeller blades with the teeth, as some of you know. And then when we go from the aggregate level down to the primer particle level, that's when we use a medium mill. So some of you use 3-roll mills, some of you use a basket mill or horizontal mill. So there's many different ways to get down to the primer particle size. And we'll cover some of these solutions today. And then, of course, is once we achieve our separation, it's always critical that we stabilize our particles in the suspension and that we choose the right additives that help us accomplish that. So Big USA, our sister company, has a good selection of different additives for various formulations or end-use markets. So we can also guide you to the right people because we have very strong relationships there. So This slide is really good. It shows you kind of the process, how it all works. So in the beginning, we use a dissolver, and then we do the wetting and the deagglomeration of our larger particles. And then once we reach the aggregate level, which is roughly between 10 to 30 microns for most products, that's when we start milling. And here you can already see a picture of our rotor. And that's when we start to use media, and we break down the particles to primary particle size. And at the end, and again, the slide show, the picture on the right shows it. We need to use the right additives to keep these products suspended so they don't flocculate back together. So this is the whole process when we're dispersing. It's just a picture of different types of pigments. I always think it's interesting to kind of show that. And then this is a good slide. It's kind of a good layout of when we start, at what point we stop using a dissolver and when we start milling. So you can see again, we start always with the dissolver. It's the first step in the dispersion process to deagglomerate. And when we reach about 10 microns, usually it's between 10 to 30 microns. This is when we start then the milling process. The reason why dissolver alone is no longer good enough or efficient enough is because we just cannot put in enough shear force into our slurry to further break up the binding forces from the aggregate level down to the primary particle level. So this is where we need more shear, and more shear we get with media, we get with different technologies. So that's when we would use bead mills. And that will allow us then to really go down all the way sub-micron range, all the way down to low nano range. And some of these new end use markets, they require in some instances below 50, 100 nanometers of particle size. So we need absolutely to use a bead mill to get us to the smaller low micron, sub-micron ranges. You can also see that for some applications, and some customers are still using them, they're the 3-roll mills. We don't make 3-roll mills. They are not really efficient. They're also somewhat dangerous and a little bit antiquated. And we have proven it over and over again that basket mill, for example, by far outperforms a 3-roll mill. But again, there are for most products or formulas, but there are some instances when the viscosity is really, really high, and the material doesn't really flow into the bead mill or basket mill. Then the only option really is to use or take advantage of a 3-roll mill. But a lot of customers are moving away from the 3-roll mill and going with the basket mill as they are much more efficient and faster. We had one instance where a customer had been using a 3-roll mill, and they are milling this material. It was a yellow, and also it was a blue, I remember. They were ink formulations and UV inks, and they basically, on the yellow, it would take them almost 18 hours to mill down the particular yellow, and very similar with the blue, 14 hours, I remember. And we were able to do that in about an hour and an hour and a half, respectively, with basket mills. So you can see a lot more efficient and also safer to use. So this is a good slide. It kind of breaks it out here. The dispersion process, and what's important to remember is when we pre-disperse, so that means we're using a dissolver. The tape speed or the peripheral speed is 18 to 25 meters per second. That's optimum. Anything more than that doesn't really improve our dispersion process. Anything lower, it'll just take a lot more time. So try to be within that window when you use a dissolver disc and you're dispersing. When we are milling, or some people call it grinding or fine dispersing, that's when we reduce our milling or rotor speed, and we go down to about 10 to 16 meters per second. And then we have a range of different products. We have the vertical bead mills, which we call an APS system. We'll talk about that. I'll show you some slides. We have obviously the basket mills, which are very popular. They're gaining a lot of traction for a number of reasons. We'll talk about those. And then also, we also offer a range of horizontal bead mills as well, where they have a place and they're very important in some of the new applications. And then we have a Dispermat SC in production. That is basically our dissolver, manufacturing size dissolver that can go up to 2,500 liters of material. So basically, as you can see, the equipment is used in many different industries. These are just some of these various end-use markets where we sell into and where customers are successfully using the equipment. So, anything paint-related, ink-related, that's all self-explanatory. We do a lot of work in the adhesives arena. We have vacuum systems, also scraper attachments with a special motor to make sure that all the product is removed from the container wall and pushed back into the middle of our container so it's properly dispersed. And then obviously some pharmaceutical applications, cosmetics is a big one, agrochemicals, 3D print media. We hear more and more customers buying that equipment, and then obviously lithium-ion batteries and fuel cell is kind of the latest end-use market that utilizes the type of dissolvers that we offer and media mills. So with that, here is a picture of just the production site. Very clean. It always looks like that. I've seen it. And there you can see these are different size dispersers. And then we have also a basket mill. So the good news is that a Dispermat is very versatile. So it means it's modular. That means it can function as a dissolver, but then it has the ability to also work as a bead mill or as a basket mill. So you just buy the attachment and then you just pop it on. There's a quick change system, and then you can convert a dissolver into a basket mill very quickly. In less than 5 minutes, you're milling. So that means you only buy one piece of equipment instead of having multiple pieces where you buy a dissolver and a basket mill. So in this case, all you have to do is buy a dissolver with a basket mill attachment, giving you much more space and the freedom to move in between different color families very rapidly because you're not tying down one piece of equipment, for cleaning half the day. You're just swapping out the baskets for different color families. So you're always practically running and operating the machinery, which is a big advantage, especially when you're running through many different colors and you want to streamline your process and you may have limited space available. And space is always scarce where, instead of having all these different machines, you get one machine with the different swappable baskets. So here is a picture of the SC. We got that in different sizes. That quick change system, what I talked about, is an option. And then you can have the combination dissolver / basket mill when you get the quick change system. There's also the ability to upgrade that to a vacuum system. So some people prefer vacuum, especially if they work with adhesives or some products where, it's difficult to transfer the product when you're done with your dispersing process from one container to the other to another container, pump it out. But if you have a lot of air trapped, that makes it more challenging. So by removing the air, so I not only have a more homogeneous type of dispersing process, but also a quicker product transfer. And also, if you think about it, especially when we are milling, these air bubbles that are inside of the slurry, they act almost like tiny little air mattresses, okay? And when you are milling, they would cushion the blows of the beads. So that basically slows down the milling process. So by removing the air, I'm now turning the process around, and I disperse or mill a lot more efficiently than having the air trapped in there. Of course, it comes at a cost, and there is also cheap alternatives. So some people choose to use, anti-foaming agents. They're very small percentage to a formula, but they are relatively inexpensive, and they can be added to also get rid of foam. So you don't maybe need the vacuum. But in some cases, customers want the vacuum. And then also on our machines, the Cover is easily removable for cleaning. And then also the cover always lifts up separately from the shaft. So you can control the shaft independently of the cover. And there are two pneumatic lift covers that basically pull up the cover and give you better access to the bottom of the cover for cleaning. And also it's very easy to remove the cover altogether if you want to do a very thorough cleaning. There's also the ability to get these machines in explosion-proof versions. So there's different, grades of explosion-proof. So depending on where you install this equipment, we can help you decide what type of explosion-proof model you should look at. So here is just a slide about the quick change system. So again, it's very quick. You can go from a dissolver to a basket mill and back and forth in under 5 minutes. Or you can also have the ability to add a rotor stator instead of a basket mill. So it turns the machine into a very efficient homogenizer or emulsifier. And then we also offer ceramic options with our basket mills. So if you're running, let's say, materials that are very color sensitive, because milling is very abrasive as a process. So if you use a stainless steel basket mill, then there is a high probability that the media will wear down the milling chamber, and that will turn it, let's say you have a beautiful white material that could turn gray because there would be bleed in from the metal that would be abrading during the milling process. So we offer that in ceramics, zirconium oxide, for example, or silicon carbide, which is more abrasion resistant, and that will basically protect your product from discoloration. Now, it's definitely more expensive, but there are some instances where it's an absolute must. Also, these new end-use markets, batteries and fuel cell, they cannot have any cross-contamination with any type of metal, so they need to absolutely have ceramic or something else, instead of steel. So that's always an option. And then also we offer the container lining in ceramic also, so that there is no issue for the product to get in touch with the stainless steel containers. And then always important when you are milling, so we need to make sure that the baskets are coolable, and then also the containers also need to be jacketed, double-walled for very efficient cooling of our slurry while we are milling. We're putting in a lot of energy, and that heats up the process very fast. So it's really important for having good cooling of our basket mill as well as our containers. And then here, just a slide of the vacuum system that's closed, and you can see it's got a really tight cover with a seal. We can also offer the ability to add a nitrogen purging valve, so you can transfer inert gas through the vessel, for either nitrogen or argon, or depending on what you want to run with. So that's also a possibility. And again, we already talked about the advantages there, that you were able to eliminate the foam and have a more efficient or improved homogenization during our milling process. That's a close-up of the vacuum cover. That's actually a smaller production scale. We make a much larger. They're not cheap, but their design requires them to be very sturdy, usually a titanium type cover, because of the pressure, and it needs to resist when you pull a vacuum. Also, the containers have to be reinforced. Many years ago, we had an instance where a customer opted to go with a cheap alternative on the container side, and actually wanted to have his own containers, and they designed them so that they would actually match up to the vacuum cover. But the problem was that they were not sturdy enough, so they were inexpensive. But when the vacuum was applied, it actually was like, sucking a hose, and it completely pulled in the container, and was actually not a good thing. It cost them a lot of money in repairs, and so always look at the build quality and the type of materials that are used, especially when you deal with vacuum. So then we also have different control capabilities. So here we have the new C technology that's also used in production for on the left. This is for customers that want to have really good upscale data and want to be able to monitor the process very efficiently. So you can show you the speed, the energy input in watts. We also show you the actual torque value, which is an indirect measurement of your viscosity. We give you the actual tip speed number, in that case 25.4. That's for actually knowing the peripheral speed or the speed of the disk. And then we have a temperature readout and a timer function. And here we can actually store all the data in batches. You can give a batch a name or a product ID, and then you basically, next time when you run the same product, it would then use the same values. You have the ability to not only run with a certain speed, but you can also run with a certain amount of energy, which is nice. For example, I can say, okay, this batch, I want to run with 2000 watts of energy. And as during the dispersing or milling process, the viscosity of my material changes, the machine would automatically adjust the speed to always maintain the energy that we are putting in. So that means if your viscosity increases, your speed would decrease because you are maintaining the same amount of energy. If your viscosity decreases, then your speed would increase if we are maintaining the 2000 watts of energy. So that also gives you a good idea of how much it will cost to manufacture a batch of product in a certain amount of time. With the C technology, what we also can do is we can program what are called cutoff values. Now, cutoff values are important because basically certain materials are sensitive to temperatures, or you don't want to exceed a certain threshold. Then you can program it so that the machine will give you a warning once it reaches a certain temperature, and then it'll give you a second warning with another temperature level. And then once it reached the final temperature, the machine would either shut off or run with a different speed or different energy input. So there is always a fail-safe to protect not only the equipment, but also the product and, of course, the operator. So you can also set up exactly the height of the blade or the basket mill inside of the container. So next time when you're running this product, all the elements exactly at the same position that they were the trial before, or the batch before. So you have very good product consistency from batch to batch, which is really important. And then on the right, you can see the standard control panel, which is great too. It's very sturdy. It's also designed so that the operator always has to have both hands on the control panel when he's moving the shaft up and down, so the fingers don't get caught between the cover and the container. So there is no way he can stick his hand in there. So you always have to have both hands on the control panel to make when he's moving or making an adjustment to the disperser, where he's moving the shaft or raising the covers up. But you cannot store any data with that more manual option. And then we have a PC controller made by Siemens. This is for customers that want to tie in other aspects of their production. For example, some customers want to add a scale, and they actually put the machine onto the scale. So they want to have that integrated into the control panel, and that would be one way of doing it, or tying in other, quality control procedures or workflow procedures. Then you can program that so that would actually work with your process in your company. So that is also available, and we do it quite often on demand when customers want it. Pilot plant, just a quick picture here. We have that in Germany. We can do small pilot trials with our dissolver as well as basket mill. And then we also offer a horizontal mill where we can do that as well. So then we have a machine. It's really nice. It's when you have an application where you don't need to change the color much, and you basically disperse and want to mill, and you don't want to change out basket mills. You want everything integrated in one. So we have this Dispermet TM, and that's a patented system. It's 2-in-1. So basically, it's a dissolver with an integrated basket mill all-in-one. So first you start dispersing. As you can see on the top picture on the right, you put your raw materials in, and then you're dispersing with the Cowles blade. And then when you are fully dispersed, then you push a button on the control panel, and then you can see on the middle picture on the bottom, now we lower the basket. The Cowles blade is still in there. It acts as a pumping wheel to push the product back to the top. And then you're milling. So you never move the container away from the machine. So it's really nice. You put it there, disperse, add your raw materials, and then you push a button, the basket mill comes down, and now you're milling. And when you're done milling, you just move the container. And that way you do everything on one machine and not multiple machines, no change needed, moving baskets around. So this is a really cool way of dispersing and milling with one piece of equipment. That's what that looks like. And then obviously different sizes are available. We also offer ceramic and the vacuum option also, and explosion proof on the Dispermet TM. Here's just some bullet points about it. It's also really good at upscaling from our laboratory scale TML to the TM production scale. Also double-walled basket for optimum cooling, and then very easy to clean also, and very, optimized for quick batch changes. Okay. So here is an example of a customer in Missouri that purchased 2 Dispermet TMs. You can see the one there, that is the installation phase. So we are installing them. The unit on the left is fully raised. You can see the basket right below the cover. And then the shaft and the Cowles blade is not attached yet. It would be behind the guy with the gray sweatshirt leaning against the blue drum. So that would be the Cowles blade. And then the unit on the right is actually lowered to the low point. That's how it was shipped. And that also does not have the blade installed yet. But basically, they're identical machines, except one would be raised up all the way to the top and one is on the bottom. And the one on the right, that's what it actually would look like when you are milling and dispersing. That's what that configuration would look like. They still run, and that was 5 years ago. I think the only thing they ever replaced on the TM was a milling disc. They have been 24/7. They're absolute workhorses, and the quality of the machines is superb. We have hardly any replacement part issues. The motors are probably the best motors on the market. You can hardly hear them when they run, even on production scale. There's hardly any vibration to them. And I always tell customers when they look at competitive machines, say, yeah, we are not the most inexpensive provider of dispersing and milling equipment, but we also didn't stop designing them in 1982, So we keep par with the times. And when you look at the technology, there is a lot that goes into making these machines to making very efficient and also hard, hassle and maintenance free for the most part. There, for example, we don't have any belts or anything like that need to be replaced, or oils or anything. So there is no issues with that at all. So they're all belt free. There's no everything is electric, and then the only air that's used is for the pneumatic lift cover to raise up the cover from the container. But that's the only thing that we use. Everything else is fully electric. So this is this quick change system. Here's the trolley that allows you to make that change very quickly. So you just lift it underneath, and then you just open up. There's a quick change. It's like a quick clamping ring that's on top. You remove that, You turn the whole assembly 180 degrees, and you pull it out, and then you just replace it with either a basket mill or a dissolver shaft, depending on how it's configured. So very, very nice design. It's just a graph on showing you the SK basket mill. Put the product there, then mill, and then you're done. So the design of our basket mill is really interesting. So we actually have a very solid wall around our basket. I'll show that right here. You know what it means. You look at this basket right here. That's a production scale TM L, and then basically the entire wall, everything around it and the top, it's all double walled. So we have superb cooling off the mill base. So now there are some competitive units that have actually screens right here on the sidewall. We purposely decided against this design. And the reason is that this is where you put in most of your energy. So that's where we are cooling. So this is why we wanted to have this all double walled for cooling. And our screen is on the bottom. But more importantly is where on the machine. If you are milling right in the center of this basket with the milling disc inside, then almost all of your beads will somewhere impact the wall at some point. So if this was a screen right here, you can imagine that you will have a very high wear of your screen during the milling process. And to avoid that, we decided to have that all solid for cooling, and our screen would be on the bottom. And that's where we have a cowls plate that sits right below the screen that actually acts as a pumping wheel almost to draw the mill base out of the basket and then push it back to the top, where then it got sucked in. There's a vortex wheel on top of our milling disc, and that vortex wheel actually draws your mill base back into the basket. Of course, the basket, you can see all the beads in there, fill them in before, and then that will allow us to really efficiently have, milling the slurry by going in and out of the basket with many, many passes. So this is a really good design compared to some of the other designs that are out there. So that screw right there is for adding the beads. You remove that screw, and then we have a funnel, and then you just fill in the beads right here. So the standard mesh size is 0.5 millimeters. For use with 1 to 1.2 millimeter beads, but we offer different screen sizes depending on the media that you want to use and how small of a particle that you want to achieve. But the standard is mesh size 0.5. Then we offer a range of horizontal media mills, which is called Dispermat RS for manufacturing, all the way from 25 liters per hour to 1,000 liters per hour. We can make them even bigger, depending on the application. Some customers use them in pass-through or circulation mode. We also offer a nano kit. We offer a vacuum option, and then explosion-proof models also that are available in the horizontal media design. So why would somebody use a horizontal media over a basket mill? That question comes up a lot. And usually the basket mill is really perfect for particle sizes all the way down to 500 nanometers. And if I have a flowable product, if my particle size requirement is below 500, then I would probably have to go with the Dispermat RS or something equivalent to really get down to super small particle size, like, 300-400 nanometers and smaller, 100 nanometers. We're probably not going to get there with the basket mill. We need to have a horizontal media mill. And the product on the basket mill has to be flowable. If you have a paste, it's not going to work because the paste is not going through the basket. I have the ability to mill very viscous materials that don't flow well with the horizontal mill by using what's called a plunger system. So actually I force my mill based on the material through the mill, and then it comes out. So that's just one of the advantages of using a horizontal mill over a basket mill. But if you look at, for example, maintenance and cost of ownership and cleaning time, the basket mill will beat a horizontal mill every time. They are much easier to take apart. That's all you have pretty much. The only wear part in there is your milling disc and maybe your screen. There are no O-rings, there are no seals, no lip seal. You can't get a leak. So it's really a very good design, manufacturing friendly. Whereas this type of mill requires a lot of maintenance and somebody who really knows what they're doing. So you almost need an engineering type employee, to really understand if there is some issue with the mill, help fix it, and just maintain it. So it takes a lot more. But again, for some application, that's a requirement, and you will need a horizontal mill over a basket mill. But we have a lot of customers now that are moving away from like 3-roll mills and move over to our basket mill design, and they don't go back. So that's a good story. And then we have what's called an APS system, as I mentioned earlier. This is really designed more or less for lab on very small scale production. Because here you have some advantages. You have basically a system where you have two containers. You have the top and you have a container on the bottom. The top container actually sits on a stand. And then you basically do your dispersing in that container. And then when you're done with your pre-dispersing, you replace the dispersing blade with a milling disc. And then you add your media. And then you would basically close it up, and then you would do your milling. And there is a purging valve on the bottom of that vessel. When you're done milling, you hook up an air hose to a socket in the cover, and then you pressurize the container. You remove the purging valve or the drain plug, and then you basically use air pressure to purge out your mill base, the milled material, into a container below. Now that can work really well up to about 10 liters of material when it's very, very expensive, what some companies already call production scale, for fuel cell applications and so on. But we have made them all the way up to, I believe, about 8 gallons. That's kind of the maximum on a custom design. The reason being it's more difficult to handle because you can add 100% bead loading to your mill base. So let's say if you have 10 liters of a mill base, you can add 10 liters of beads. So that means very efficient milling, very quick milling, also very easy to clean. Because you just put the drain plug back in place, you fill up the top container with a cleaning agent with the right polarity, and you run the mill again, and then purge out, the waste the same way that you did the mill base, and then you rinse and repeat until you have a clean vessel and clean beads. So that's a really easy way of cleaning. But again, we have a size limitation. We can't go higher than that because the problem is that the volume of beads that are required. So imagine if you had a 1,000 liter or 2,000 liter container and you mill a ton of product, you would need 1 ton of beads. And that's probably cost prohibitive, and also the handling, how you're going to handle a ton of beads, the weight and all that. So that makes the APS system really not efficient for large scale manufacturing, but for very small scale and very expensive materials. But also excellent for the lab. And then here we have a picture of our lab in Germany at VMA. They have a lot of capabilities there. If you're ever over there, you have an affiliate or your company over there that needs to come in or wants to take a look at the equipment, please be our guest. We also have the same in Connecticut. Obviously, it's a little smaller, but we have a lot of more materials in there, more machines. We have a very nice video on our YouTube channel. We can actually see all the different machines. We have a horizontal medium mill called SL with the nano kit, and we have an AE6 with the C technology also in there, for really good for upscale, giving you all the different options. We have different basket mill attachments, rotor stator. We have a vacuum system, so we can really do a lot of testing in Wallingford, and we always welcome when customers say, hey, before I buy, I want to see the equipment. Can we do an upscale trial? Can we look at that? What does that look like working with the basket mill, for example? Then, we'll love to have you. A day will not cost you anything. We would cover that, except your travel and your hotel, you pay that, but we would not charge you for any type of lab time. And then we would be able to show you the value of the equipment and help you maybe even scale up. We'll have somebody from the additive business, a chemist, supporting us in case there are questions about formulations or you need formulation improvements. So that's also something that we can offer because of the synergies that we have with our counterparts at Big USA. And then finally, customers sometimes want to come in and use it as a milling or dispersing training and seminar location to bring people in to learn more about the equipment or the dispersing milling process. So with that, I think we're right on time. We'll turn it back to John and see if we have any questions.
Yeah, thank you, Andy. Good stuff as always. And I love always ending that on the Wallingford lab, because that is such a great facility for testing for our additives folks right there. So yeah, if anyone's interested, reach out. You can simply hit reply to any of the automated marketing messages you receive. It'll come to my team, and we'll funnel it to Andy and his team. And they're the real technical experts here. So we have a few minutes left. If anyone has any questions, comments, are experiencing some challenges in their facilities, please jot it down in the chat, and we'll get to it. Until then, Andy, a couple questions that I have just listening to this. I love the flexibility, and I love the fact that VMA-Getzmann is committed to innovation. It seems like we're always, innovating. The C technology is a great example. We have the new stuff coming out in the next, month or so. Is that right? I don't know if we can talk about it yet, but that's coming. American Coating Show, if anyone's going to be there, definitely stop by. Andy and his team will have some of the dispersers and media mills on display. So check that out. But thoughts, Andy, when you are first working with a customer and when, they're starting a program like this, maybe they haven't got into dispersion, but they've grown to the point where they need some. What are the starting points that you'd suggest?
Well, first of all, I think that the customer should have an idea of why do they need to disperse or mill. So we would first analyze, or with the customer in a discussion, understand the application and see what the end goal is. Where are they trying to develop an additive, or are they going to make an end product? And so whatever the application is will kind of dictate the direction that we will go in. Are we dealing with solvent-based products? Are we dealing with waterborne? What is the makeup of the formula? And then obviously we would discuss, volumes. We would need to know, are we doing this, very small scale? How much volume are you trying to get to? We look at what are they doing presently. Most customers already have experience, and we see a lot of customers that want to move from a 3-roll mill over to a basket mill, right? So we would ask a lot of specific questions about, length of time and volume and type of product, and then gear it towards, like, let's say, okay, we have these parameters. We need to know the viscosity, how well does the product flow. Are there any other challenges or hazards? And then we would pick is color fastness important? You don't want to have, when we mill, we always have to be sensitive that milling is abrasive, and are there any cross-contamination issues or metal contamination issue that could impact the color? I mean, we've seen, TiO2, slurries or white products are always very sensitive, and we need to use ceramic components if we want to maintain that color. But we would always ask, if they are really interested in, adding production or lab capability even to, send us, some information about their formulations. We can do a non-disclosure and basically come to our lab with your product, and then let's run it and see how does it disperse, how does it mill, what milling system is most suitable, and what would give us the fastest and most reliable results. We can measure particle size distribution, particle size. So all these things are important when you make a decision on what equipment to implement. So a trial is always critical.
Yeah, no, great. Thank you for kind of walking us through that process. Got a question in here regarding choosing the right equipment. Can you talk a bit about nanoparticle dispersion at the lab and the manufacturing process?
Okay, so nano is a wide topic, right? So depending on what type of material are you trying to mill, is it a coating? What is the application, and what is the particle size? Is it just 900 nanometers, or are we talking about something like sub 100 nanometers? So first of all, if we go anywhere below 500 nanometers, we're kind of limited to the type of equipment. We will have to use a horizontal media mill. Anything above that, basket mill is free game, which is perfect. For cost of ownership is better, and also the way you maintain the equipment, so it's a lot easier to maintain. There are nano kits available, but we also offer nano kit for the production scale, and then basically we would decide with you and your application where we would start out. We would start out with, let's say, 1 to 1.2 millimeter bead, and then we would successively get smaller and smaller with our beads or screen size to get to the final point where we need to go. But most critical here is really bead selection, as well as the right material of the layout of our milling system to make sure that there is no cross-contamination issues that come into play, especially when we're nano milling.
No, great. And that's a good point. I mean, for those out there listening, getting into this, Andy and his team can help recommend different processes. They can look at what you currently have and recommend enhancements to improve efficiencies, improve quality, all of those things. So, they're not just selling a solution. They're a consultant really on this whole process, and they are really they're as good as it gets. So you can pay me later for that, Andy. Just kidding. Just kidding. No, it's a great team. Another question in here, lab to bulk upscaling. How do you better correlate lab mixing time versus production mixing time?
So that's a great question. Basically, that depends on the formula, really. It's very difficult to say up front, but usually our machines upscale really well. So in some instances, we are almost at a ratio 1-to-1, especially with the basket mill approach. But the important part is that you remember, obviously you have your volume, so you need to look at all the upscale parameters should be the same, right? So the diameter of your blade or your milling disc, the ratio to the container, if you're basket milling, the filling ratio, the temperature, the type of milling system, the material of the milling system. So, the height of the milling tool inside of the container. The tip speed is very critical, the amount of energy you're putting in, what the actual speed. So there is a lot of these variables should be the same. If you have them the same, then you should expect very close correlation to the lab, at least with our equipment. So you should never be probably more than 50% more time on manufacturing than you're in the lab. At least we haven't seen that with our equipment. Like most time, we're 1-to-1, or we may be 15 to 20% more time in manufacturing, because there's obviously a longer path, the product has to take to go through the mill and everything. So it adds processing time just by the nature of of our dimensions. But in general, if you optimize everything like you would do in the lab, and the seed technology that we have was designed really to give you the best possible upscale performance. That's really needed when you want to go and have very close correlation between your lab to your manufacturing process. So that's we talked about that earlier in the presentation, the value of that.
Yeah.
So that's what you can expect with our equipment.
Nice. And I think as we wrap up, maybe one last thing. I know that with our Quick Connect, it really helps with time and cleaning and, keeping that uptime as opposed to spending hours cleaning the machine. Would you mind touching on that just a bit?
You mean on the on the basket mill? So
Yeah.
basically that's the quick change system there is designed really to give customers the ability to run quick color changes. So if, for example, right now, if you have a basket mill in your manufacturing arena, what happens? You run a blue and somebody comes in and says, hey, it's time to run the white or a yellow.
Exactly.
What you're gonna have to do is you're gonna have to shut down the machine, and you're gonna have to disassemble the basket, and you have to clean it. Usually take out the beads, clean it really thoroughly so you don't have any cross contamination. That takes time, and you're tying down this particular piece of equipment. Now, the modularity approach with that, quick change system, customers would do a quick flush when they are done with one color, and then they just remove the basket, and then they just pop on the basket for a different color family. So it can be running blue in 1 minute, and 10 minutes later, I'm already running my red or my white, because all I did was I swapped out the basket.
Nice.
And that is the key to maintaining efficiency, right?
Yeah.
I'm always tying down my equipment for cleaning, then I'm spending money on that, but not where I really need to spend my focus and time and money is on manufacturing products, So it's all about cost savings at the end of the day, and space savings also. That's why I say with customers, when they use horizontal mills, I said, okay, write down how many hours and how much time it takes every time you need to change a color. And then you figure out the cost associated with that color change.
Yeah.
And then you look at a basket mill. I mean, it's honestly, it's a no-brainer. You will have the payback very rapidly just by changing the milling system. Efficiency is everything.
Yeah, if you're not running, you're not making money. That's what it comes down to, basically. So I think we'll wrap here. Some good questions, good conversation. Thanks for elaborating, Andy. And like I said, you're going to be getting a link with this recording. Feel free to share it with colleagues. Check it out later. Take some screenshots, whatever you need. Also, if you have any questions, if you think of something later today or next week, just hit reply to any of those email or the marketing emails, and we'll funnel it to Andy and his team. But I want to thank you, Andy. As always, appreciate your insight and knowledge about this. And thank you for attending. We look forward to seeing you on future Bitgardner web seminars. Thank you.
Yeah, thanks everybody. Appreciate you coming online today.